Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through the power to a power and zero index. So these are more index laws dealing with powers. So let's start with power to a power. What does that mean? Well, it's when you have something like this, 2 to the power of 5, and then you raise that to a power. We have a power to another power. So we want to write this in index form. I'm not going to evaluate it. 2 to the power of 15 turns out to be like 32,768. It's a massive number. I would never ask you to do that in your head without a calculator. What we're going to do is just write it in index form. So index form means something to the power of something. So how do we go about this? Well, remember, raising to the power of 3 is the same as timesing something by itself 3 times. So this is the same as 2 to the power of 5 multiplied by itself 3 times. But we know from the multiplication index law, the first index law that we've already learned, when you're multiplying bases, you keep the same base and you add the powers. So 5 plus 5 plus 5 is 15. So 2 to the power of 5 to the power of 3 is 2 to the power of 15. But we want to do that without writing this in expanded form because that could take a while. Imagine if it was 2 to the power of 5 to the power of 10. We wouldn't want to write this out 10 times. So there is a quick way. We can go straight from here to the answer without having to write out in expanded form. You just keep the same base and we multiplied the powers together because adding something to itself many times is exactly what multiplication is. So if you had something like 3 to the power of 8 to the power of 7, quick way to do this, keep the same base and multiply the two powers. 8 times 7 is 56. So that's the power to a power index law. What about the zero index law? Let's start by looking at what 2 to the power of 0 is. So it's probably natural for you to think, okay, 2 to the power of 0 is just 0. But it's actually not. You see, 2 to the power of something, we've always thought of that as multiplying this base 2 by itself this many times. Can't really multiply 2 by itself no times. That doesn't make any sense. So what mathematicians have done is they've said, we're going to come up with a value for 2 to the power of 0 so it's consistent with other index laws. You see, 2 to the power of 0 is the same as 2 to the power of 1 divided by 2 to the power of 1. The division index law we previously learned says if you have a base divided by the same base, you keep the same base and you subtract the powers. 1 minus 1 is 0. But 2 to the power of 1, 2 divided by 2 is definitely not 0. It's actually 1. Anything divided by itself is 1. Now I could have used this logic for any number. I could have done 3 to the power of 0 or 4 to the power of 0 or negative 200 to the power of 0. The only number it wouldn't work for is 0. So what am I actually saying? I'm saying 0 to the power of 0 is undefined. If you put it in your calculator, you get an error. But anything else to the power of 0 is actually equal to 1. So this says A is not equal to 0. Any number except for 0, when raised to the power of 0, gives 1. So that means 2 to the power of 0 is 1, 3 to the power of 0 is 1, 7 to the power of 0 is 1, minus 2 million to the power of 0 is 1. I know it's a bit tricky to understand, but the reason is because when you're raising to the power of 0, you're dividing by itself. So what would be 5 to the power of 0? Well, anything except 0 to the power of 0 is 1. 5 to the power of 0 is 1. What about something like 5 times 3 to the power of 0 versus this? Now, here we need our order of operations that we've previously learnt. See, BIDMAS says brackets, index, division, multiplication. So we have to follow that order of operations. In this one, we do the brackets first. What's in the brackets is times. 5 times 3 is 15. So this is 15 to the power of 0, but anything to the power of 0 is 1. This, on the other hand, because of BIDMAS, we need to do I, index, raising to a power before the multiplication. We do this one first. 3 to the power of 0 is 1. So this is just equal to 5 times 1, which is 5. So make sure you understand the order of operations. All right, let's now do a couple of trickier questions. So these are the two index laws I went through on the previous slides. We had 1 and 2 in a previous video. Index law 3 says if you raise a power to another power, keep the same base and multiply the powers. Remember, BC means B times C. If you don't have an operation written between pronumerals, it always means times. The fourth index law we learned is that anything other than 0, when raised to the power of 0, gives 1. So let's look at something like this. I'm going to evaluate it, say what it equals. So here I'm using a pronumeral. The index laws apply to pronumerals just as they apply to numbers. So I'm saying k does not equal 0. Then this thing here, I have to do the power first. K to the power of 0 will be 1, since k is not equal to 0. So this will be 7 times 1. Now here, I'm raising the whole thing to the power of 0, not just the k. So anything to the power of 0 is 1. Of course, if k is not 0, then this thing will not be 0. So 7 times 1 is 7, subtract 1 is 6. That is my final answer there. So in this question, we're going to figure out what number goes in the box. So it might not be obvious to you, but we're actually going to use index law 3 to figure this out. See, the thing is, 8 and 4 are both powers of 2. So I'm going to write 4 to the power of 18 as a power of 2. So 4 is 2 squared. So I have 4 to the power of 18. See, 4 to the power of 18 is the same as 2 to the power of 36. 8, on the other hand, is 2 to the power of 3. So what I have here is 8 to the power of something equals 2 to the power of 36. Which number goes in the box? Well, we know from the third index law that 3 times this number gives 36. So what do you times by 3 to get 36? Well, of course, that is just 36 divided by 3, which is 12. So it turns out if you do 8 to the power of 12 and 4 to the power of 18, you'll get the same number. Doesn't matter if you don't know what these numbers actually equal. I would never ask you to do 4 to the power of 18 without a calculator, but these will be equal because of the power to a power rule. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.